This is Britt Caswell with another example video. In this video, I'm covering example 1 from section 3-5 in the SavvasRealize Algebra 2 textbook. So in this example, we are using zeros to graph a polynomial function. So first I want to start with a little bit of vocabulary for you. Here in our polynomial, we have what are called factors. Right? This is written in the factored form. So each thing being multiplied together here is called a factor. Now to get a zero, what you need to do is you need to set each factor equal to 0. So to find my zeros, I'm going to take x and set it equal to 0. I'm going to take x minus 4 and set it equal to 0. And then I'm going to take x plus 3 and set it equal to 0. So by doing that, I was able to solve and get 3 separate x values, which I'm going to use to help me to graph the function. So here I am with a coordinate plane. Should have used common sense when making this video and put a coordinate plane on there, but whatever. So here we are, there's our coordinate plane. So I know I'm going to have one of these at 0, 2, 3, 4, and negative 3. So then what we need to do is we need to determine what our end behavior would look like and how these how the line should travel through the graph. Alright, now there's a couple ways to do that. You could pick some test points and plug them in. In fact, that's what I'm going to do. You could multiply this out and check out the end behavior from the first term if you wanted. Something like that. It doesn't really matter. What I'm going to do is I'm going to pick some test points. And I'm just making sure that I alternate. So here I'm at negative 4 on the graph, so I'm going to plug in f of negative 4. negative 1 is another easy number, so I'm also going to plug in f of negative 1. Positive 1 is another easy number, so I'm going to plug in f of positive 1. And then I need to get the last end behavior here, so I'm going to do f of 5. And so what I'm doing is I'm testing to see whether those points should be positive or negative, and it's going to give me an idea of whether the graph goes up and down or what. So let's go ahead and try it. So everywhere there's an x, I'm plugging in a negative 4. So I have negative 4 times negative 4 minus 4 times negative 4 plus 3. So I have negative 4 times, this would be negative 8, and this would be a negative 1. So here I'd have, trying to make sure I have enough room. Here I'd have a positive 32 times another negative would make it a negative 32. So at f of negative 4, I have negative 32, which I'm not going to mark the y-axis. I'm just going to say it's down there somewhere. So this graph, I know, will come down like that. Actually, I should do it in another color. So I know this graph's going to come down like that. Alright, so now my next one, I'm going to try f of negative 1 to see where it falls on this line. So I have negative 1 times negative 1 minus 4 times negative 1 plus 3. So negative 1 minus 4 is negative 5. Negative 1 plus 3 is a positive 2. Negative times a positive comes out positive. And so 1 times 5 is 5, times 2 is 10. So this is up here at 10, like that. Now I know that my graph has to turn back around to go through this other 0. So what it probably looks like is some kind of bump like that. Okay. So then now I'm going to try f of 1. So I have 1 times 1 minus 4 times 1 plus 3. So I have 1 times 1 minus 4 is negative 3, and 1 plus 3 is 4. So that turns into a negative 12. So that means that this comes down like this. So my graph, I go from the 0, and I know it's going to come like that somehow. And then I just have to check out that tail end to see what it would be. Now I could tell you now that each of these factors only shows up once. So because their power is 1, this is going to behave like a line and go up still. But I want to show you why it still goes up. So here I'm plugging in 5, and I should be getting a positive number. So I have 5 times 1 times 8, which is 40. Which is how I know that it's going to be up here somewhere. Alright, so this gives me like a rough sketch of the graph. I don't know what my absolute minimum, or sorry, my relative minimum or relative maximum are there, but I know the general shape of the graph, and so that's kind of cool. Another way I would have known this general shape is there's 3 factors, so this is going to act like a cubic function anyway, which tends to look kind of like this. Alright, so now this one gets a little wilder because it asks us to actually factor the function first, which could be a little stressful. So my first step to factoring is I'm going to factor out the GCF. Because if you notice, these all have x's in them, so factoring out that GCF is really going to kind of clean this up for us. Okay, so my greatest common factor is 4x here, because a 4 can go into all of the terms, and we could take an x out. So when I go to factor out that 4x, the rest of the polynomial turns into x squared plus x, and then 24x divided by 4x is a minus 6. Now when they say to factor this function, they mean to put it all in linear factors. Like you see how there aren't any exponents on these x's, they're all linear. That's what our goal is with this problem as well. So now that I've factored out the GCF, then I'm going to factor out this quadratic here. Alright, so I'm going to write that here. Factor out the quadratic. So don't forget that that linear, or that 4x that we pulled out is still there, okay? It doesn't just go away just because I'm factoring another part of the problem. So this doesn't have a number in front of the x squared, so I could set up my double bubble, which I know has an x and an x. The first plus falls down, and to get a negative 6, I have to have opposite signs, so this one's going to be a minus. And then what multiplies to make 6, that subtracts to make 1, that's going to be 3 and 2. So now we have it factored out. Okay, this is the factored form. So then we need to find our zeros. Now remember, to find the zeros, you're going to take each factor and set it equal to 0. So each thing being multiplied together gets set equal to 0. That's the zero product property, remember? So here, if I divide by 4, I get that x is 0. Here, if I subtract the 3, I get x is negative 3. And here, if I add 2, I get x equals 2. So these are my 3 zeros that are going to go on the graph here. So I have a 0, negative 3, because these things are counting by 2's, and a 2. Why they would make them count by 2, who knows? It's kind of ugly, but whatever. And so then what we need to do is we need to, we could identify our end behavior. So let's go ahead and let's do that. Just because we already have it in its standard form. So if we have 4x cubed, because that 4 is a positive, the right side goes up. And because this is cubic, the left side is opposite, which means that it's going to go down. So from here, I know I go up, and from here, I know I go down. So that saved me from having to do the extra work for these other test points. However, I still don't have all of my graph on here, so I'm going to pick my test points between 0 and -3 and between 0 and 2 so that I could tell how the graph behaves in here. All right? So here I'm going to say test points. So I'm going to find f of between 0 and -3. I'm going to use -1 because that's going to be an easy one. And I could use it either on the factored form or on the non-factored form. I think I'm going to find that the non-factored form is easiest for these numbers. Oops. I should say -1 squared, sorry. Alright, so there's where I'm going to find f of -1. And then I also need to do a test point. It's going to lie right there, just so you know. So somewhere on that blue line right there. I'm also going to try f of 1, which will get me this point right here as well. And that one's going to be really easy to calculate because 1 to any power is 1. So like here, 4 times 1 cubed is 4. 4 times 1 squared is 4, and 24 times 1 is 24. So that gets me -16 for f of 1. So this would fall, these are counting by 5s, so that would be about right there. So we know that for this part of the graph, it at least comes down and then back up like that, which is kind of cool. Now for -1, remember if it's to an odd power, it just switches the sign on this. So this is -4. If it's an even power, the sign stays the same here. So that's what we're looking at. So -4 and 4, they cancel out, leaving me with 24. So this one is going to come up to like right here on this graph. And then we could do a very rough sketch where we connect them like that. So that's kind of the rough sketch of the graph. Alright, and then it looks like we just have one more example of this, so we'll go ahead and we'll give it a shot. This one, I'm going to be factoring using the difference of squares formula, just because I know that I have a 4th power, which is even, and 81 is 3 to the 4th, just so you know. So, difference of squares formula. Remember, it says that a squared minus b squared is the same thing as a plus b times a minus b. So in this situation, where I have something to the 4th, I'm going to call this x squared and this 9. Okay, so this is going to turn into x squared plus 9 and x squared minus 9. Now I'm going to use the difference of squares formula again because this is also a difference of squares. Okay, if ever you see the 4th power stuff, you're going to use the difference of squares twice. Now the x squared plus 9, just leave him alone. But the x squared minus 9 is going to turn into x plus 3, x minus 3. The sum of squares here, the x squared plus 9, that's going to get us imaginary answers. All right. So I could find the zeros on that, but they're going to be imaginary, so they won't actually be on the graph. So here we go. So the zeros, I'm going to put the x squared plus 9 on there just to show you guys how to get the zeros. Here's x plus 3, x minus 3. So these ones are easy, right? I could subtract the 3 and get x equals negative 3. And I can add the 3 and get x equals positive 3. So those two zeros are really easy to find. They're going to be here and here. Now this one, the x squared minus 9, all right, plus 9, I'm going to minus 9 from each side. So I get x squared equals negative 9. And then I'm going to take the square root of each side, and don't forget to put the plus or minus. Now the square root of 9 is 3, and then when I have that negative under the radical, it turns into an I. So this does not appear on the graph, okay? It'll cause some bends in our graph. I don't quite know where, but it doesn't cross the axis at all, so we just kind of leave it alone. So now let's check out our end behavior. Okay, our leading term is x to the 4th. So because I have a positive 1 here for my coefficient, the right side goes up. Okay, that comes from the positive 1. Now because I have an even exponent here, the left side matches. So that means that the left side is also going to go up like this. So then I would pick a test point. I'm just going to pick out 0 and see what I get when I pick my test point. Because 0 is nice and in between those. So I'm going to do g of 0. And let's see what we get. So 0 to the 4th is 0, so I'm just left with a negative 81. So that's going to be like right down here. So the graph is somehow going to come down like this. Now a lot of times these to the 4th graphs kind of look like a W. So I could pick some test points like 2 and negative 2 and see if it makes a little W shape, but I'm not terribly worried about it. You could check it on Desmos to see how the bump would show up. But there we have it. So that is how to use zeros to sketch a polynomial, and how to use the test points to see kind of whether it should go above or below. Until next time.